Okay, in this video segment, we're going to talk about metals, nonmetals, and metalloids, and kind of how we find them on the table, and also some of the properties that they may have. So when we look at the periodic table, we see that our metals are the bulk of the actual elements on the periodic table. They span everything from group 1, your alkali metals, all the way through the transition metals and the metals under the stair-step line. And again, we have this extra row now that a lot of the old periodic tables don't show. So imagine this stair-step line coming down in here, and then we're actually just going to carry it straight down from here, and we'll keep the halogens all in that non-metal kind of category over here, okay? And then also your inner transition metals down here, also your metals. So all of this stuff is metals, and then what we have is on this side, we have this kind of orange area. These are your non-metals, okay? So on your periodic tables, if you don't have this, go ahead and draw this in, where start between boron and aluminum and kind of draw in this dark line and go down over, and almost stair-step your way down. And then when we get here, it really doesn't matter if you go straight down or if you go over and down. We don't know enough about these elements anyway to really determine their metallic characteristics. So I won't ever ask you about these last few elements in terms of if they're metals or non-metals. So really this is the point that you got to end it. But you can, if you want, either slide it straight down or move it over one more and down if you need to finish out your staircase. So these are your metals over here, and then you have your non-metals in this region. So the majority of our elements are metals. We do have a bunch of non-metals, and then these purple ones sitting on this chart right here, these are considered metalloids. So they have some characteristics of metals, some characteristics of non-metals, but they're not one way or the other enough to actually classify them as a metal or not metal. So we give them this term metalloids. A couple to note in particular, right here, this is aluminum. So if you take a look, aluminum is number 13 on our periodic table. Notice how it sits on this stair-step line with the rest of the metalloids, but aluminum is not considered a metalloid. Okay, so make a note of that in your notes, make a note of it on your periodic table or someplace. Because it is one of the metals that touch this stair-step line that are not metalloids. Okay. Besides that, everything that touches this stair-step line is considered a metalloid. Sometimes polonium number 84 right here is also considered a true metal and not a metalloid. Again, it's not one I'm going to really test you on, but the aluminum one is one I do need you to remember. This is not a metalloid. That aluminum is truly a metal. Okay, in terms of our different elements. Now, when you start talking about metals and nonmetals, like what makes them a metal, what makes them a nonmetal? Well, we have a chart. Now, there's more properties than just this, but these are the ones that are really easy to identify. Okay? And the first one is probably your most common used property to identify a metal versus a nonmetal, and that has to do with conductivity. So if you are a metal, you are good at conducting electricity and you're good at conducting heat, all right, so, or heat energy. Nonmetals tend to be very poor conductors of electricity or very poor conductors of heat. To give you a comparison, the worst metal is still over 100 times better than the best nonmetal at conduction. So there's a huge gap between metals and nonmetals in terms of how well they conduct electricity. Now your metalloids, those are your semiconductors. Probably the most famous of these is silicon. So silicon is one of our metalloids. We actually utilize that concept or that property of silicon to be a semiconductor in all of the computers that we have in the world. So all computer chips right now are made out of silicon for the most part, and silicon's ability to semiconduct or for our ability to control the conduction of silicon is one of the key pieces to building computer chips. So it's a key property of that one semiconductor or that metalloid that actually is helpful for us in our world. Now, another key property that we tend to see is that metals tend to be malleable and ductile. Malleable just means bendable, and ductile means the ability to draw into a wire. So you can bend and shape metals pretty easily, and you can actually form them and extrude them into wires really easily. Nonmetals tend to not be very malleable. So think of like sulfur. Sulfur is a nonmetal, or phosphorus is a nonmetal, or iodine. They're all nonmetals. They tend to be really brittle. They break and they crack and that kind of stuff if you were to hit them with a hammer. Whereas metals, if you hit them with a hammer, they tend to dent. So they tend to be more malleable and ductile. Metals you can shine to a high luster, so they look shiny to us, whereas nonmetals tend not to. Metals almost always lose electrons when they ionize, so they end up being positively charged, whereas nonmetals tend to gain electrons, so they're almost opposite of each other. And then metals tend to corrode. So if you look at metals, they tend to combine with oxygen pretty easily and to corrode or to rust, basically. And then in nonmetals, a lot of our nonmetals form those diatomics that we talked about before. So instead of corroding or rusting and attaching to oxygen, they tend to bond with themselves if they can, forming diatoms or diatomics. Even some of the nonmetals like sulfur and phosphorus actually form polyatomics, which are groups of 6 and 8, or these big, huge circular molecules of themselves also. So they tend to bond with themselves when they need to. Now, if you look under metalloids, all this stuff is kind of variable. So for metalloids, besides its ability to semiconduct, you really don't have good information about the metalloids because each one is so unique and individual that you can't give it a classification. But the easy thing about metalloids is they tend to do a little bit of both. So they might have something it might be malleable, but no luster to it. Or it might lose electrons, but also form diatomics. So it might have some properties of metals and some properties of nonmetals. Okay? This will be a good distinction for us later on in the year because we talk a lot about what metals do in terms of bonding versus what nonmetals do in terms of bonding. And then, of course, we kind of throw those metalloids in whenever they need to in that process. So that's another way for us to actually classify things on the periodic table is by metal, nonmetal, and metalloid.